What if you have a bunch of numbers and you want to add them up? This happens a lot in calculus. So what if you have, say for instance, you want to add up the first 100 squares? Well, I guess one thing you could do is you could just start adding them. Of course, this is better done on a computer and is not particularly the most fun you could have. Perhaps you use a spreadsheet, again, a computer, or you spend a lot of quality time adding up numbers by hand. Well, regardless of how you do it, how do you even write down this problem in a convenient way? In particular, this dot, dot, dot that I've got, the ellipsis in there. What does that mean? Well, that's a little bit ambiguous, isn't it? I can kind of fill it in a bit if I knew typically what I want here. Typically, a typical term is going to be some number squared. What's n? N is going to be 1, then 2, then 3, then 4, and so on. This n is the index, and this n squared that I'm adding up is the general term. So for instance, I could, in this sum, call n squared the term, and this n the index. And with this in mind, there's a nice notation that kind of summarizes and makes it pretty clear what it is that you want. I want to add up. I want to sum up n squared, my term, and I want to sum it up from a certain index. So let's see, the first index is for 1 squared, so that index is 1, and the last is 100 squared. And the notation we use is this sort of squiggly line. It's a capital Greek letter sigma, sigma for sum. So this is called sigma notation, and it's pretty convenient. And if you break it apart, here's the index variable. This is the starting index, and this is the stop index, and this is the general term. Well, that's pretty convenient. Nowadays, this terminology is old, but nowadays you might think of this as a little computer program. You might say that, well, I start out my sum is 0 because I haven't added any terms, and then I say something like for n equals 1 to 100. Do something. What am I going to do? Well, I'm going to take my sum and bump it up by n squared. Something like that might capture the same idea as that sigma notation. And in fact, if you have some sigma notation, that's perfectly fine to write it as a computer program and give it to your computer, provided there's only finitely many terms. If there's infinitely many terms or an unknown number of terms, your computer's going to have a problem with that. Okay, so how do we find these sums in general? If I were to give you a general sum and say, add it up, could you do it? Maybe. The answer in general is no. But for specific tricks, well, there are specific tricks for specific sums. And let me quick cut to the chase here. There is a Wikipedia page that's got lots of them. So this is the Wikipedia page for summation, and there's quite a few of them here. So for instance, this one right here, the sum of the first few numbers, is actually pretty easy to cook up. So let me show you how that goes. This particular summation goes back a long ways, although mathematicians like to tell a story about the mathematician called Friedrich Gauss, who apparently rediscovered this when he was a child. He was told to add up the first 100 integers, like this. And what he realized is that this is something that looks a bit like this. And he said, well, you know what I bet I could do? I bet I can pair up these numbers in a nice way. See, if I add up the number 1 and the number 99, I get 100. If I add up the number 2 and 98, I get the 100. And if I keep going, 3 with 97, and so on, eventually I'll get to 49 and 51, which also add up to 100. And then I get two terms left over, a 50 and a 100. And what he realized is he said, well, gosh, how many 100s do I have? Well, I have 49 hundredths right here. I've got an extra 100, so I actually have 50 hundredths. And I got one extra 50, so a little bit of regrouping. And I have 101 times 50. So the answer must be 5050. That was a clever trick. It turns out it works in general. So the general formula looks a bit like this. So now I'm distinguishing between a lowercase and an uppercase n. And what is the formula? Well, if I just follows that pattern, so if I look at it, it's n plus 1 times n over 2. And actually, surprisingly, the formula works whether n is even or odd. And you can see right away that this gives you the 101 times 50. But as I said, in general, if I give you an arbitrary sum, it's going to be a little bit of work to figure it out. For some of the simpler ones you can. There's a little trick that works a bit like this one here. So for instance, the sum of squares that I've got going on here, actually there's a nice little pattern. There are the so-called triangular numbers, because they add up little triangles. But when in doubt, just go head over to Wikipedia and ask, and you see if there's a formula. And actually there are books and other places that you can find these formulas as well. But the short answer is this sigma notation is very convenient for describing sums that have an arbitrary number of terms in them, and possibly even you might take that upper limit to be infinity. Take a limit to say I'm going to take lots of terms.